Hello everyone, welcome to Lectures by Aparna. Today let's discuss the very basics of electronics, which is PN Junction Diode. So a PN Junction Diode is obtained by connecting metallic terminals across the two ends of a PN junction, and its symbol is like this. This is the P-type region and this is the N-type region. So let's see the working of a PN junction first. A PN junction is formed from a single semiconductor crystal, and in the semiconductor crystal, one side is doped with trivalent impurities to make P-type region, and the other side is doped with pentavalent impurities to create N-type region. This is done mainly by ion implantation method, diffusion method, etc. These are special fabrication techniques, and thus a PN junction is created. Now, in a PN junction conducts current only in one direction. In the reverse direction, it will offer a very high resistance value. So the current flows only in one direction. In the P-type region, holes will be the majority carriers, and in N-type region, electrons will be the majority carriers. So this is how a PN junction, just when it is formed, looks like. This is the P-type region and this is the N-type region. Those shown in green color are the ions. In the P-type region, there is negative ions, and in the N-type region, there will be positive ions. Those shown in red color, they are the majority carriers. In P-type region, it will be the holes, which are the majority carriers, and in N-type region, electrons will be the majority carriers. Those shown in dark blue color, they are the minority carriers. So in P-type region, electrons will be the minority carriers, and in N-type region, holes will be the minority carriers. So this is how this PN junction will look like just when it is formed. As time goes by, it will not look like this. Okay, that we will discuss later. So PN junction can be considered, we are considering three conditions of PN junction. First condition is no bias condition, where no external voltage, without giving any external voltage to the PN junction. Second one is forward bias case, and the third one reverse bias case. So these are the three conditions we are considering. In today's class, we are discussing the no bias condition, that is when no voltage is applied across the PN junction. So let's get started. As soon as it is formed, it will look like this. So what happens here is that the majority carriers from the P-type region, which are holes will start diffusing across the junction. These holes will move towards the N-type region, and the electrons from the N-type region will move across the junction and go to the P-type region. Then after crossing, they will recombine with these, that is, these holes will cross the junction and recombination with the electrons happen. Okay, why is this diffusion happening? Why are they crossing this junction? There are two reasons for it. One reason is the kinetic energy they have, since they are mobile. Ions are immobile, but these holes and electrons, they are mobile. So they will possess kinetic energy. So one reason is the kinetic energy they have, and the second reason is the concentration concentration gradient. Concentration gradient. That is, in the p-type region, holes will be the majority carriers, whereas in n-type region they are minority carriers. So here in p-type region, holes will be more in number, whereas in n-type region, holes will be lesser in number. So they move from a higher concentration area to a lower concentration region. So the concentration gradient is one reason, and the other one is kinetic energy. Likewise for electrons also, in this side electrons will be more, in this side electrons will be less. So they tend to cross the junction and move to p-type. But this diffusion that take place only for a very short time. After that what happens is that it will happen like this. That is, a depletion region or space charge region will be set up. I'll explain how this depletion region is formed. So as these majority carriers from p-type, which are holes, they will cross and reach the n-type. So in this, these positive ions, those free electrons which had, they will recombine with the holes. Okay, so these positive ions will be left uncompensated. Similarly on this side also, holes, electrons will cross this junction and recombine with the holes of these ions. As a result, these negative ions will be uncompensated and they will be there. So this positive and negative ions, they will create an electric field. These shown in dotted lines, they are the electric fields that is created by this ions. This electric field is called the barrier. This creates a barrier, and this region is known as the depletion region. Now, the physical distance of the depletion region from one side to the other side, that is this width. This is called the barrier width. And the potential difference between the both sides, that is from this side to this side of the depletion region to this side, that potential difference is known as the barrier potential or barrier height. It is also called barrier potential or barrier height of the barrier. So these terms you should remember. Now for silicon, this barrier potential will be about 0.7 volt, whereas for germanium it will be 0.3 volt. Okay. Now we saw what happens with the majority carriers. These holes cannot cross again once this depletion region is formed, because these positive ions will repel these holes. So once the depletion region is formed, these holes will not be able to cross the junction and move to the n-type. Similarly here also, these electrons in the n-type will be repelled by these negative ions. So they will also be not able to cross the junction. So the diffusion of the majority carriers will be stopped. Now what happens with the minority carriers? These electrons will be attracted by these positive ions. So these minority carriers will cross the junction. Here also the minority carriers is holes. They will cross the junction as these negative ions will attract them. But this flow of minority carriers is very less compared to in the starting there was diffusion of the majority carriers. So this minority carrier diffusion is very less compared to that majority carrier diffusion. So this minority carrier diffusion can be neglected almost. So this is what happens with the majority carriers and minority carriers when no bias is given to the PN junction. Now by connecting metallic terminals across this can be made into a diode, and biasing, when biasing is given, it will behave in a different way. Forward bias and reverse bias condition of PN junction diode. So this is the condition when the PN junction is forward biased. When it is forward biased, from the metallic terminals the voltage will be applied, and to the p-type region positive terminal of the battery will be connected, and to the n-type region the negative terminal of the battery will be connected, and under this condition the PN junction will be forward biased. So what is happening when it is forward biased? The majority carriers in the p-type region is holes. So these holes will be repelled by this positive terminal. The holes will be repelled by the positive terminal and they move towards the junction. They will be forced to move towards the junction and they will cross the junction. In the n-type, the majority carriers are electrons. So these electrons will be repelled by the negative terminal. The electrons here will be repelled by the negative terminal, and these electrons also are compelled to move towards the junction and cross the junction. So these holes will cross the junction and recombine with the electrons. These electrons will cross the junction and recombine with the holes. As a result, the depletion region starts to decrease. As the depletion region width decreases, more carriers will cross the junction and the current will increase. So what is happening here? The electrons in the p-type region, they will break the covalent bond and move towards the positive terminal. The electrons will be attracted towards the positive terminal. Similarly, in the n region, for each recombination that is happening, an electron will enter into the n-type region. So the electron flow is in this direction and the hole flow is in this direction. The direction in which holes are flowing, that direction is known as the conventional current flow direction, I. So this I is the forward current. Forward current. Now what happens when the PN junction is reverse biased? When it is reverse biased, the PN junction will look like this. So these purple color things are the metallic terminals, and from the metallic terminals the voltage will be given like this. To the P region, negative terminal of the battery will be connected, and to the N region, positive terminal of the battery will be connected, and thus the PN junction will be reverse biased. So what is happening in reverse biased condition? The majority carriers here, which are holes, these holes will be attracted towards this negative terminal of the battery and they move away from the junction. Similarly, in n-type region, the electrons will be attracted towards this positive terminal and they move away from the junction. As they move away from the junction, the depletion region width will increase, and so there will be no current passing through this junction. Now, what happens to the minority carriers? The minority carrier in P region is electron. So these electrons will be attracted by these positive ions. So they cross the junction. Similarly, in n-type region, the minority carriers are holes. These holes will be attracted by this negative ions and they cross the junction. As a result, there will be minority carrier current. This current remains constant up to a particular temperature. So when temperature is made constant, this current, which is known as reverse saturation current, will be constant up to a particular voltage. But when this voltage reaches a particular value, the diode will break down. Breakdown means at that particular voltage, the current due to the minority carriers will increase abruptly. and that voltage is known as the breakdown voltage. Now what happens here? This depletion region is a region of high resistivity, and this P and N regions here, they are having low resistivity. So this P and N regions act as plates of a capacitor, and this depletion region will act as a dielectric, and this will create a capacitance. This capacitance is known as transition capacitance or depletion capacitance. So these are the terms associated with reverse bias condition. Now let's see the VI characteristics of PN junction. VI characteristic means it is a graph that is drawn between the voltage that is applied across the terminals of the PN junction and the current flowing through the diode. So this graph gives the value of current at any value of voltage. Okay. So this positive value of V is the forward bias condition, and this negative value of V is the reverse bias condition. So in forward bias, up to a particular voltage there will be zero current, and when voltage reaches V0, which is known as the cut in voltage or knee voltage. So when V0 is reached, the forward current will start increasing. So V0 is equal to 0.7 volt for silicon, and it will be equal to 0.3 volt for germanium. That is when the forward bias voltage overcomes the potential barrier, current will start flowing through the diode. This voltage is known as the cut-in voltage or knee voltage. Now the forward current, if it increases very high value, when it reaches very high value, the diode will not be able to handle the heat that is produced. So the data sheet specifies a particular value of the current that the diode can handle, forward current. That forward current is known as the maximum value of the forward current. So that will be specified in the data sheet. So that is this here, IF max. Now what about the reverse bias condition? Reverse bias condition, the voltage will be negative. So in the reverse bias condition, there will be the current flow due to the minority carriers. So there will be a reverse saturation current up to a particular voltage of Vz. Vz is the breakdown voltage. So at breakdown voltage, the current increases rapidly, but up to that the current remains almost constant, and this current is known as the I dash sat, is known as the reverse saturation current. So this is the VI characteristics of the diode, and this portion gives the forward bias condition and this gives the reverse bias condition. If this video has helped you, please do subscribe to my channel. Thank you.